Hey guys, John the Quant here. Today we are pulling order book data from the Lobster itch system. Now, Lobster stands for Limit Order Book System, the Efficient Reconstructor. The service was started in about 2013 and it mostly provided data for academic researchers, but fairly recently it's kind of expanded that and it's now used by researchers in investment banks or hedge funds or really just kind of all over the place. Um, Itch refers to NASDAQ's total itch data system. And we're going to be doing a separate video or maybe a few videos about getting data directly from NASDAQ. But Lobster has data from 2007 all the way up to about 2 days ago. And in my opinion, it's much easier to work with than trying to get the order book data from NASDAQ directly. So it's really a great resource to be familiar with. You can check it out at lobsterdata.com. And let's head over to Colab and see how it goes. All right, right now we're looking at the Lobster Data website, lobsterdata.com. So you guys can go here, check out what is Lobster, get some more information. They got data samples, access options, and you can look it up to become a member. I think you can get with a single subscription, you can get data for about 10 people. So it's not a bad deal. They work with NASDAQ. They work with this German university. And, they got access to some articles and stuff. But let's go over to Colab. Now, hopefully, I've zoomed in enough you guys can see what's written here. We've imported warnings and just ignored them. We're going to need path. We're going to use chain to kind of build the column names. Pandas and NumPy and Matplotlib and Seaborn. Now, the first thing that I did here was I set the path. I created this folder called data. And I'm just making the column names here. So what I'm doing is I'm getting ask price and a number and then bid price and a number, and I'm chaining all this stuff together. And so this cell creates this list of column names: ask price 0, ask size 0, bid price 0, bid size 0. And that's going to serve as column names for the data frame that we're eventually going to make. Now I needed this to get the data from the website. All right, so this says that the SSL certificate could not be verified, and I said that this is fine. Just download data even if you can't verify the certificate. And then this part, which I stole directly out of another notebook for some AlgoSeek data access stuff that I'm working on. What this does is it downloads a zip file, or it accesses a zip file, and then it extracts the information in that zipped file and only saves the extracted file. So this was very helpful. It's pretty simple too. We're using zip file and URL lib and IO. Not too bad. Hopefully you guys can read what's going on in this, because this little snippet has been used a lot. I've used that snippet a lot lately. All right, so that downloads and extracts the file, and now we can open it. I chose to open Amazon on June 21st, 2012. And that's the order book that I'm opening. It's a CSV file. I'm reading it in, and this is what it looks like. So I set the columns that I made earlier: ask price 0, ask size 0, bid price 0, bid size 0, and so on. And how this works is ask price 0 is the best ask price. This ask size 0 is the order size for the best ask price. Bid price 0 is the best bid price. Bid size 0 is the order size for that best bid price. And you can see here, this is actually $223.95 and 0 hundredths of a cent. Whereas the best bid price is $223.18. So we've got a spread there of, what is that, 77 cents it looks like. Not too bad at all. And so further down, you can see we've got about 270,000 bid and ask prices for the day for, what was it? It was June 21st, 2012. Just arbitrary day. Amazon, arbitrary but recognizable company. And each order book file that you get from Lobster, it also has to have messages attached, and that's going to tell you the time. Okay, it's the seconds after midnight at which the event happened. What kind of event was it? You can see execution of a visible limit order or a hidden limit order, submission of new order, and so on. Then the order ID, which is a unique reference number, the number of shares in that order, the price, which is the dollar price times 10,000, which yields that price to the hundredth of a cent that we saw up here, and the direction. So -1 is a sell order and 1 is a buy order, but a sell order indicates that a buyer initiated the trade. So a market maker would place a limit order. It doesn't have to be a market maker. Somebody, though, is placing a limit order where they want to sell at a certain price. And then when a buyer comes and says, I want to buy that from you at that price, that is what initiates the sell order. So that initiated the opposite. Okay, a sell order is initiated when a buyer decides to buy, and a buy order is initiated when a seller decides to sell. I know it's weird and confusing, but I don't know how else you would possibly simplify that. So we're going to open the message data file. We've got the date here. It is 2012, June 21st, 2012. And we've got 10 levels of data that we're looking for here. Now, this one, Lobster path, and we're getting all of the data from Amazon. We're just inputting those things here. You can see, if we go back up here, this is the same file that we're opening. We've input the date here and the number of levels that we want, which is 10. You guys can see we go from ask price 0 to ask price 9, which is 10 levels. So we're just doing this in a more modular way so that you can just change the date or the number of levels very easily and get the data out, no problem. And then the message data will read that CSV file, and it's got these columns: time, which again is the number of seconds after midnight at which an event happens; event type, so this one is 5, and that refers to the execution of a hidden limit order, or 1 right here, which is the submission of a new order. Order ID, which is just the reference ID, 0 because it's hidden. Size, all right, how many shares are in this order. The price at which it was executed, this is $223.82, 81 cents, 96 cents, 75 cents, and $224. And the direction, this is a sell order, which means it was initiated by a buyer. This is a buy order. This is another sell order, a buy order, and a sell order. Further down, you can see here again, 270,000 observations for that day. And with those columns, you can see that they are the same number as up here. So how many executions were visible? Now that we're exploring the data, that's our first question that we really want to ask. So event counts, we've got a count of how many times each event happened. Which one was execution of a visible limit order? It was number 4. So let's look down at that. It was about 9,000. Okay, so number 5 was execution of an invisible or a hidden limit order. So down here shows us about 79% of all executions were visible. This number divided by the sum of these two numbers is what we're looking at. But you know, the event types are great, but they don't really tell us what we're looking for. So here I've just changed it. 1 is a submission of a new order, 2 is a cancellation of an order, 3 is deletion of an order, 4 visible execution, then hidden execution, and so on. And so I'm just mapping the new things, the new, you know, informative, I guess, information into it. So you can see down here, 5 becomes a hidden execution. 1 becomes submission of a new order, and so on. And that just makes it to where somebody can open up the data frame and read it and understand what's happening without having to check the documentation all the time to remember which kind of event is which. And then I changed the time to the actual time. So time is in the number of seconds since midnight. So the first thing to do would be to change the time column to a time delta. in seconds. And then if we get the date, which is June 21st, 2012 down here, then we can take that time delta and we can start from right here. This starts it at midnight, 000000, and then we're adding that time delta onto it to get the actual time at which the events happened. And you can see this is down to like sub milliseconds, very, very minute time-wise. And then I just dropped the date column. And now we can look at that. So our first one, the execution of that hidden order, okay, the hidden execution that we looked at earlier, happened, of course, on July 21st, 2012, and it happened right at 9:30, just a few milliseconds after 9:30 in the morning. So now we want to combine the message and the price data, okay? So up here at first we had all the bid and ask prices, but we want to combine those with the events that they are stuck to. All right, so that way we have a time series of those bid and ask prices. So that's what we did here. In this one, we just concatenated these two data frames because they have the same number of observations. We concatenated them. Axis equals 1 to stick them together column-wise, side by side. And then we just look at the whole thing. We can see that we have the time here, the event type. This is all the same as before, $223.82. It's a sell order, hidden execution. But now we have the bid and ask prices at that time. So right at 9:30, when this event occurred, the best ask price was $223.95, and the best bid price was $223.18. And you can see all of the top 10 bid and ask prices at that time. And then the next event, which happened, just a few milliseconds later, which was a submission, we've got the same best bid and ask prices, and so on. It just keeps going. So looking at all of that, we've got now the same. These are the same columns as our message data, and then we've just stuck on all the columns with the bid and ask prices onto the end. Now, if we want to just pull out the executed trades, then this is actually easier using the event type, the numeric event type, rather than the description of the event. So if the event type is in 4 or 5, 4 is a visible execution, 5 is a hidden execution. So we're just going to pull out the executions out of this whole data frame. And we're just going to look at the head of that one. Of course, the first one is still that hidden execution that we've been talking about, but here's a visible execution for 21 shares at $223.81. It was a buy, which means it matches with this bid price up here. See that? This one and this one match up. And that should be true. Look at this one. This is another buy right here, and its price matches the best bid price from before. And these hidden executions, they don't have to play by exactly the same rules because they're hidden. All right, and then looking at the tail, the last one happened just milliseconds before, it looks like 4 o'clock, probably when the exchange shut down, of course, at 4. And it was a visible execution for 51 shares at $220.51. It was a buy order. And let's see, it correlates with this best bid price from before. Now, the best bid size had been 300, so after this person bought 51 shares at $220.51, there were now only 249 of those shares left. Okay, so hopefully you guys can understand what's happening. And don't worry about it. We're going to look at a chart later that kind of shows all this stuff a little more intuitively. But that's how this works. You get your best bid price, all right, and then it's a buy order is executed at that bid price. And the number of shares at that bid price goes down by the number of shares that were bought. All right, so there were only 11,419 executed orders on that day, even though there were 270,000 events. 11,419 of them were executed orders. And now we're going to make a chart. We want the bid prices to be blue and the ask prices to be red. We're going to use this date time package or module, whatever you want to call it, in order to sort the data and make our plot. Then this just makes the plot. So what it does is I'm making the figure size 20 by 8, and then I'm using the time column for the executed orders. Then I'm looping through, okay, range 10, because this goes from 0 to 9, and those are the bid and ask prices that I have. I have ask price 0, bid price 0, and so on. So I'm looping through 0 through 9, and then I'm looping through bids and asks, and then I'm creating this Y column, which is from the executed. It's going to be first bid price 0 divided by 10,000 to put it in regular dollars, and then it's going to be ask price 0, and then it's going to be bid price 1 and ask price 1, and so on. So it's going to loop through all of those columns, and then C right here is going to be the size. So it's going to first be bid size 0, then ask size 0, then bid size 1, and so on. So it's looping through the size columns. And then we're plotting all of those right here. That's what that line does. X is the time of the event. Y is the what am I thinking? Price. Oi. Y is the price. Okay. C right there is going to correlate. Is controlled by. It doesn't correlate with. It is controlled by the size of the order. The size of the limit order. And then we're going to color them. Bids are blue and asks are red from up here. Size is 1, Vmin is 1, and Vmax is the 95th quantile. And all that stuff just serves to make it look nicer. And then we needed to set the X limits, and I set them to 9:30 in the morning on June 21st, 2012. So this is the start of the day. The first event, if you remember, happened right at 9:30, just a little bit after. And it ends at 4 o'clock. So this is 16 o'clock on June 21st, 2012. And if you remember, the final executed order happened just milliseconds before 4 o'clock. And we just make it look pretty by despining and fitting it in a tight layout. And this is what it looks like. So as you can see, the ask prices, the 10 best ask prices, have a little bit of a spread up here. And then the 10 best bid prices, the blue ones, form a kind of a thick blue line that just kind of follows. And sometimes you can see a little bit of white in between whenever the spread thickened up. So this is what the price of Amazon did throughout that day. And if you were to look at just an intraday plot, it would probably show you the middle. The middle of this would be what it showed. Okay, the middle of that spread. And then the next plan was to plot all. Well, how is this different? Sorry. Okay, yes. So this one is just for executed trades. Sorry. This is the bid and ask prices for executed trades, and this is the bid and ask prices for every event, not just executed trades, but every event that happened. So you can see it just looks a little bit more flattened out or filled in, maybe. But there you go. What we did in this notebook was we loaded the Lobster itch data. We pulled out the specific company and day that we were interested in and sorted through it and just made this nice bid and ask plot. All right, let's go back to face and just wrap things up. There you go, guys. Not a whole lot to say right now. Hopefully you watched all of that and you can see how easy it was to pull that order book data in and sort through it and really get exactly what we wanted, that intraday order book bid ask spread, and hopefully you guys can understand why an algorithmic trader would really want to be able to do this. I mean, that's exactly the kind of information they would need in order to plan their trading strategies and their timing and stuff, so as to limit, slippage and market effects, and to really kind of be able to predict what the market was going to do. But all that information, is for another day. So if you enjoyed the video, or if you didn't enjoy it, or you wish I had done something different, I would love it if you let me know in the comments. If you learned something here, go ahead and like the video. If you want to keep learning with me, subscribe to the channel, and we'll keep doing this kind of interesting stuff together. All right, have a great day.